So there are four types of polymer on the basis of molecular mass, and they are elastomers, fibers, thermoplastic and plasticizers. So first topic is elastomers. In this type of polymers, the intermolecular forces operating between the adjacent polymer chains are very weak. Due to the presence of very weak intermolecular forces, the polymer chains can be stretched over 10 times on the application of stress, and they return to their original position on the removal of applied force. Elastomers have randomly coiled molecular chains of irregular shape having a few crosslinks on the application of force. These randomly coiled chains straighten out and the polymer is stretched. However, the alternative force between the polymer chains being very weak, polymer chains cannot maintain this stretched form. Therefore, when the force is withdrawn, the polymer chains return to their original position due to the presence of some crosslinks. Thus, the presence of weak intermolecular forces allow the polymer chain to be stretched. The cross links in the polymer chain allow the polymer to come back to its original position. Example of elastomer is rubber. The another polymer is fibers. These have strongest intermolecular forces in the form of hydrogen bonds or dipole-dipole interactions. Due to the presence of strong intermolecular forces, these polymers have high tensile strength, lower elasticity and sharp melting point. Example of fibers are nylon 66, terylene, dacron, orlon, etc. Next is thermoplastic. In this type of polymers, intermolecular forces of attraction are in between those of elastomers and fibers. Thermoplastics have linear polymer chains with a few chemical bonds acting as crosslinks. These are hard at room temperature. Thermoplastics have little or no crosslinks, and hence polymer chains can slip past one another on heating. Next is plasticizers. Certain plastic do not soften very much on heating. However, this can be easily softened and made workable by the addition of same organic compounds called plasticizers. Example, PVC is extremely stiff and hard, but it can be made soft and rubber-like by adding N-butyl phthalate, a plasticizer. Okay, next topic is classification based on stereochemistry of monomer. First one is isotactic. Isotactic, Greek meaning of isotactic is same order. So, isotactic polymer in which the side chains or groups are orientated on the same side of the main polymer chain having regular and definite order. Let's see the example CH2CHR, 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 CH2. Here the order is same. So, this is isotactic polymer. Next is Syndiotactic Polymer. Syndiotactic. Greek meanings of syndiotactic is alternative order. So syndiotactic polymer in which the side chain or groups regularly alternate on both sides of the main polymer. CH2, CHR, CH2, CHR, CH2, CHR, CH2, CHR, CH2. Here the groups or chains they are in alternate order. So these are called syndiotactic polymer. Next is atactic polymer. Atactic, Greek meaning is no order. So atactic polymer in which the substituents are arranged in an irregular random pattern are known as atactic polymer. Example: CH2 CHR, CH2 CHR, CH2 CHR, CH2 CHR, CH2 CHR. They are in irregular and random pattern and they are known as atactic polymer. Next topic is classification based on composition. So let's start. Here is Homo Polymer. What is Homo Polymer? A polymer obtained from identical monomer units is called a Homo Polymer. Example: polythene, PVC, Teflon. When ethene polymerization, polythene and PVC polymerization. Okay. Next is copolymer. A polymer obtained from two different monomers is called a copolymer. Example of copolymer: nylon 66, which is a copolymer of hexamethyl diamine and adipic acid. When the repeat unit occurs in a long sequence, that is in blocks of the same type, the linear copolymer is called block copolymer. D block A B B. Here the repeating units A and B. 3 block, that means A B B A. Here the repeating units is A B B A.